So Newton laws we discussed. Newton first law we discussed, and Newton third law we discussed. So Newton third law we have action and reaction, right? We have action and reaction, and now today we are going to discuss Newton second law. So before I do Newton's second law, I need to introduce few terms here. I need to introduce linear momentum. Momentum. Linear momentum is defined by definition is P is equal to m times v. M is the mass, v is the velocity. P is the momentum, linear momentum. This is the definition. Now, example. Suppose this vehicle m and has a velocity here, and that velocity is a constant velocity, right? So if m is equal to 2 kilogram and v is equal to 5 ms minus 1, which is a uniform velocity. Uniform means it's a constant throughout the motion. So if that happens, this keep going with v velocity, right? It's a constant. So what would be the momentum? So momentum is equal to m times v. That would be 2 kg times 5 ms minus 1. That is going to be 10 kg ms minus 1. The units are important too. Now you have to understand, in reality we have things that you can feel. For example, force you can feel. If someone pushes you, you can feel the force. The velocity you can feel. Okay, when you are driving your car, you can see that you're moving, right? Then mass you can see, right? Mass is like your body, you can feel it, you can touch it, right? So those things you can feel, but this velocity you can feel, this mass you can feel, this momentum you can't feel. It is a derived quantity. It's a mathematically derived quantity. Okay, I'll tell you one thing. When you eat food, right? When you eat food, you can feel the food, right? Yep. Can you feel the vitamins inside? Can you feel the protein inside? No. You can feel the bulkiness of the food, right? So likewise, but inside that there is something that which can't feel, but it is there, right? So likewise, momentum you can't feel. If someone asks, okay, force you can feel. So that's why we say it's a mathematically derived quantity, which is the multiplication between mass and the velocity. All good, guys? Yeah. Now another example. Okay, you have a car here, which I would say MA, moving with u velocity. There is another car here mb, move initially the velocity is 0. Then what will happen here? Collision is happening, right? Collision, right? Because the first car A is going to collide with B. Yeah. So after collision, suppose that they stick together. They stick together, MA and NB. They stick together, and then V1 would be the velocity here. You see the situation here, right? Now we say this here, we say this one is before collision. This one is after collision. Okay, so now what you need to find is find the momentum before collision. B, find the momentum after the collision. C, find the momentum difference. Do that. So find the momentum before collision. So that would be before collision, mass A has MA U plus mass B has MB V, but that is 0. That would be MAU only. Why? Because this is 0. Right? So find the momentum after collision. After collision, they stick each other, yeah? So it's going to be MA plus MB. That's the total mass. Stick each other, so V1. Right? So momentum difference. Right. Momentum difference is delta P, we call it. Before momentum before. Say momentum mom before minus mom after. So momentum before is MAU minus momentum after would be MA plus MB V1, and that is momentum change. Okay, no issue. Now what you have to do, another example here. Right, what you have to do is do the same thing for this situation. Now this is MA, this is U of A, then you have another car here, MB, and this is U of B, and then collision is happening here. Collision is happening here. So what is happening now after collision? MA is moving with V of A. Here M of B, which is V of B. Yeah, all good? Right. Ranjit, are you there? Yeah. Okay. So now, if you logically look at this situation, UA should be greater than UB, right? Why? Because otherwise it wouldn't collide, right? And we will make an argument here, VA is less than VB. Yeah. Right? So now if VA is less than VB, that makes sure that this is not going to collide with this one again. Right? So this is the situation, right? Now what you have to do is, you have to find again these three. So put ABC and then find the initial momentum, final momentum, and then the momentum difference. Okay, find that. Okay. So now the first one, find the momentum before collision, right? So before collision, find the momentum before collision. So first one, that would be MA UA plus MB UB. B. Find the collision after MAVA plus MBVB. Right? Then C, momentum difference. So you can say typically you can say that this one is your momentum initially, like this. This one is your momentum final. So delta P is momentum initial minus momentum final. Now that would be just copy paste. So when the values are there, it's just a matter of putting the values there, right? Okay. Now next question I'm going to raise here is this. Same question, okay? Same question. D part I'm going to put. Now, collision time. Okay. Collision time is T is equal to 0.01 second. Collision time is T is equal to 0.01 second. Right? Right. Find the rate of change of. Find the rate of change of. Find the rate of change of momentum also explain what is happening when they collide. When they collide, also explain what is happening when they collide in terms of rate of change of momentum. Okay, think about it. There is something to think physically. Now, collision time T is equal to 0.1. Find the rate of change of momentum. Okay. Now, rate of change of momentum P is defined as rate of change of momentum. Rate means always time. So that means delta P divided by delta T. So delta P is what we have here, right? So I'm not going to put those things. P final, P initial, minus P final divided by delta T is 0.01. Now if you think about the units here, second here it's going to be kg ms minus 1, right? So now the total unit would be kg ms minus 2. That would be rate of change of momentum. All good? Yeah. So but these values you can find from here. So when these details are given to you, you can find that value, right? Not a big deal. That is not what we are thinking of here. So we are thinking of how to find the rate of change of momentum. So why I asked you to find rate of change of momentum, I'll let you know in a bit. Now also explain what is happening when they collide in terms of rate of change of momentum. Now think in this way. I will help you to think. This is where the collision is happening. There is a momentum here, momentum initial, before, and there is a momentum here after, final, right? So the momentum change is happening here, delta P is happening here. Delta P is happening because of the collision. Otherwise, initial momentum continues, right? You understand that? Yeah. So the collision is doing something here. Now the question is asking, also explain what is happening when they collide in terms of rate of change of momentum. Okay. Now delta P is there. Also delta P over delta T also there. Right? So why? Because collision time is there, right? Collision time is delta T. Right? Now before I do this business, I will tell you something, like you guys doing so many subjects, right? The delta, this is called capital delta. You do other subjects as well, chemistry and all those other things. Capital delta. This delta is called simple delta, like simple A, capital A. Right? This delta or this delta we use typically for two situations, right? For two situations. Okay, what is that?
Difference in something.
So one thing is difference. The other thing is, other meaning of delta is small. So for example, delta T in chemistry means difference in temperature. That delta has that meaning, so we understand through the context, right? Difference in temperature. If I use delta M, again you will use this in chemistry. We never talk about difference in mass typically, right? We can, it's situation dependent, but we use small mass. Okay. So if you do chemistry 2, unit 2, or if you do chemistry unit 3, you will have an equation like delta Q is equal to MC delta T. Unit 2 or unit 3, both you will have that, right? So especially you will learn this in unit 2 if you talk about the water. Even in physics we did that, right? So here delta T means difference here, difference in temperature. This delta Q means again difference in heat, right? So you have to understand that, you have to understand the context, then only you understand that, right? The difference between small and difference. Okay. Now then what is this one? This is difference in momentum. What is this one here? This delta t, small time. So now you understand the collision is happening in a very short time, right? So this time is very small, right? So and that you can see from the question as well. T is equal to 0.01. Essentially, this is nothing but your delta t. Easy? Yeah, easy. Yeah? Okay. So now logically I will show you this because this is indeed important, right? This is indeed important. Now look, there is a collision, so that's why Pi becomes Pa. They are two different. If there is no collision, what will happen? Pi continues. So then this one also Pi. Right? Now due to this collision, the collision is happening within this time frame. Due to this collision, there is a change in momentum. You can see PF, PA, or Pi to PF. Now, mathematically, knowing this delta T and then delta P, you can find rate of change of momentum. Rate of change of momentum means what? Momentum change with time. Rate of change of your knowledge. How your knowledge is changing with time. So, rate of change of your knowledge is high means you learn quickly, right? So, rate of change of momentum is there, that's fine. Now you have to understand, when the collision is happening here, there is a force exchange, right? I mean, I'm moving, I'm colliding, see? There is a force exchange between my hand and the wall of the band, right? So, you understand, collision is happening, after that there is after motion, this is before motion, but here, because of this collision, there is a rate of change of momentum, right? You can visualize that, and at the same time you will feel that actually there is a force due to that collision. Collision means force, right? Forcing, right? So how come this force is involved in this business? That is what we are going to discuss. You understand what I'm saying? Yeah. Now, okay, force involvement. Okay. So now understand, when this object is going to strike on that, at that instant, look at this, at that instant you are going to get a force here. This guy is going to get a force here. This is A object, this is B object, right? So now this force, okay, listen carefully, this force on A object given by B, that force. This force is acting on B, acting on B object, given by whom? Given by A. Do you understand that? Right? So that means if you separate this one to visualize what is happening, if you separate, you will see that on that wall this F is happening, on this wall this F is happening. Right? Yeah. Now do you understand why I did Newton's third law first? Right? So if you look at this collision, action reaction is happening. Newton's third law. Action reaction is happening. Right? So yeah. So according to Newton third law, right? These forces are action and reaction to each other. These forces are action and reaction to each other. Okay. So you understand, if they are action and reaction to each other, is there a net force? No. There is no net force. So there is no net force. Okay, there is no net force because they are balancing each other, right? There is no net force. If you think this collision as a system, that means you consider this collision as a system. That means you consider that this collision, the whole thing, as a system. That means 0.1 second, right? So we'll extend that. Here you can see this is giving a force that way, this is giving a force that way. You can see actual reaction is happening. I'm going to consider this motion, and then at this instant this considered to be a system, one single object. So if you consider that situation one single object, so F force and F force is like that, so that means action reaction is cancelling each other. But after that they will pass like that, that's fine. But if you think about that instant, that particular instant, right, for that moment action and reaction, they are cancelling each other, and after that they are passing, right? So that's why I'm saying, so there is no net force if you think about that instant, right? They are cancelling each other. If you think this collision as a system, so this as a system, if you consider that as a system instantaneously, so this is happened. It's all conceptual, you can see. Any question? Any question? No question. Okay. Now what we have discussed, we discussed about rate of change of momentum here, right? And all of these things we discussed. So, but our original question was, original question was this: Newton's second law. Now, still we didn't discuss Newton's second law. We discussed about linear momentum as a subtopic first, and then gave the definition, and then we saw that that momentum before collision, after collision in the situation, right? And we did that math, right? So before I move into the other part, you will do this question. Okay, this is the question. Think about this. There is a wall here. There is a wall. Okay. Now, this ball, which is M, moving towards the wall with u velocity, and it's going to hit here, right? It's going to hit there. After collision, this is before. After collision, so it will turn back, and then will have the same, it will turn back and will have the same velocity u there. So this is after. Okay, my question is, find the momentum difference. That means find the momentum change, in other words. Yeah. Okay.
Different direction.
Hmm?
Or like,
You don't believe this question, right? Typically, when I do that, I do all of these things in motion. This time VCE, they gave this concept with a different lesson, which is called, we have light and matter thing, right? We will discuss that. They connect this one with that. So they took a electron there. So electron is moving and colliding and coming back. So that electron theory, that theory is used with this concept there. But I mean, that is not a magic actually, because we know this one in physics, right? And there is just a connection and do papers and we go. Okay, anyway. So direction matters or not? Direction matters. Why? If direction does not matter, the momentum change is zero, right? Okay, now you go back here. You go back here. Okay. So there is a direction, there is a finite, look at this, there is a finite momentum change. Why? Because of this collision, right? There is a momentum change because of this collision, right? If there is no collision, what will happen? This becomes zero. Why? Because this becomes pi. So pi minus pi is zero, right? Divided by delta t, zero, right? Yeah. So that means if the momentum difference is zero, that will tell you what? No collision. Yeah. So now she's asking good question whether the direction matters. If you don't count the direction, you get delta p to be zero, right? If delta p is zero, that means what? If delta p is zero, that means there cannot have a moment, there cannot have a collision. But you can see there is a collision, right? Right? You will see there is a collision. So delta p cannot be zero. Makes sense, yeah? So direction matters, yes. Okay. Direction is important, right? Now, direction is important means what? That will tell you a big thing actually. What is that? If direction is important, that will tell you a big thing. What is that?
momentum as a direction.
So, momentum is a vector. So, that means P is a vector. See, it's easy. Right? So, definition of the momentum then. So, definition of the momentum is P is equal to m times v. Right? But now you know the actual definition of the momentum would be P vector is equal to m times v vector. Now, if you are a specialist student, now you will see it's bloody easy, right? So, m is what? M is a scalar. Scalar times vector is going to be a vector. Pops up, right? But you don't need that. You don't need, for physics, you don't need this one. You don't need that one. You are playing with the scalar value. You are playing with the scalar value. What do you mean by scalar value? According to, okay, this is for those two. So, scalar value means what? Scalar value means P vector magnitude is equal to m times v vector magnitude. This is not for physics students, other two. So, then this is nothing but sorry, this is nothing but P and mv. So in physics we use the magnitude version of the vector equation, right? Why? Because otherwise it's a problem, because they don't know vectors and all those business, right? But I showed you the stuff logically so that you know that momentum has a direction, otherwise you get the answer 0. That is not a realistic answer. Why? Because there is a collision. Easy. Okay. So if you want to find the momentum change here, delta P is equal to P initial minus P final. So you say P initial is mv mu, right? Mu right hand side minus mu, this is left hand side, right? Right. So what you do, you change the direction by putting plus here. You can change the direction, that bit you have to know, the physics people, right? So note here, that is inside physics. Note here, if you have a velocity here, vector, you can write that this way, minus v. That's a fact. That fact physics people should know, right? This fact. So that is used here. All good? So the answer would be, that's why you got the answer, 2 mu. Delta P is equal to 2 mu. All good, guys? Yeah? Okay, so now background is fine. You know what is momentum, momentum difference, rate of change of momentum, how that counts towards the collision, and yeah, all of these you know now. Everything is covered. Next one, Newton's second law. We call it N2 law. Okay, so Newton's second law. So in Newton's second law, right? Newton's second law. What is Newton's second law? If I ask this question from a year 10 student and even in year 11 student, they were taught to say F is equal to ma, right? F is equal to ma. Newton didn't say that. Newton didn't say Newton's second law is F is equal to ma. Newton said this. Okay, I will precisely tell you what Newton said. And if you get this question in the exam, this is what precisely you have to write. If you say F is equal to ma, wrong, 0. Newton's second law says, Newton says, external force acting on a body is directly proportional to rate of change of external force acting on a body is directly proportional to rate of change of momentum. That's what Newton said. Now we have to pay attention rate of change of, we have to pay attention external force. Now rate of change of momentum means delta P divided by delta T. right? External force is Fext. This is what Newton said, right? Then what we can do, directly proportional. Directly proportional. So directly proportional means F external is directly proportional to delta P divided by delta T, right? Now you know in math how to convert a proportionality to a equality. How to convert a proportionality to a equality. So you do that, you put an equal sign, you replace proportionality by this, you have to put a constant there. That's how you convert. This constant we call proportionality constant. Proportionality constant. This constant is called the proportionality constant. All good? Yeah. Later, scientists found that this proportionality constant is equal to 1. How come? By experiment. They found it by experiment. Okay. So we conclude F external is equal to delta P over delta T. Okay. What is delta P now? P initial minus P final for an object, right? So what is P initial? M Vi, right? What is P final for that object? M Vf. Yeah. So then I can write this one, M Vi minus M Vf. Easy? Yeah. So F external is equal to delta P divided by delta T. So I'm giving you all of these things so that when you have a question you can logically think. Delta P is MVI minus MVF. You just plug those values there. Delta T. Then you can see M is common. Factorize it. You take M out. So Vi minus Vf. I'm going to write delta T underneath this. Right. So when you do that business, what is this here? Velocity difference divided by time. Go to grade 6 selective school. Speed difference divided by time. Speed divided by time? Acceleration. Distance divided by time? Speed. Distance divided by time is speed. Velocity divided by time or speed divided by time? Acceleration. So this is nothing but acceleration. Okay, so that is nothing but acceleration. Easy? Easy, yeah? Yep. So now can you see F external is equal to MA? Right. Now can you see why the people are saying Newton's second law is equal to F is equal to MA? They are missing quite a lot in that description. Can you understand that? Right. So they are talking about the after product. Right. F is equal to MA. Easy. But Newton didn't say that. Right. So Newton didn't say that. Don't write that. You get 0. But when you do questions, yes, you use that. But when you define it, you are not going to define it. You are going to define Newton's second law in this way. External force acting on an object is directly proportional to rate of change of linear momentum. Okay. You can see rate of change of linear momentum is proportional to the external force acting upon that. That is the Newton's second law. So when you derive it, you get this one, but you don't take the after product, but you use that for that purpose. Any questions? No question? No. Okay. Now, then we'll discuss this question. Yeah. Understand? There is a car here, cart M, starting from 0 time. There is a constant force acting on that. F is equal to 10 newtons. Force is defined by newtons, right? And then initial velocity is going to be 0. Initial velocity is going to be 0. Right? So M is equal to, I would say, 1 kilogram. M is equal to 1 kilogram. So now this is going to travel to this location here, and it will take 5 seconds to do that. Now velocity, right? Velocity we don't know. Still M is equal to 1 kg. This force still is applied 10 newtons. Now the distance between these 2 points, distance between these 2 points would be 20 meters. Okay, find V. So find V. V means final velocity. Now this is so practical here. Look at this. This is so practical here. Think about this is your car, right? So you are on cruise. You are on cruise. So cruising means what? Cruising means you are providing a constant force, constant torque on tires, right? So you are cruising it. So suppose your force is 10 newtons, right? So you are starting from 0 velocity. That means at rest, right? So you are on cruise. Suppose. So you are cruising that. Mass is 1 kilogram. Time is 0, right? You see that. And then after 5 seconds, what will happen? This moves to this location where the distance is 20 meters. Final velocity at that instant you don't know. That is what you need to find. M kilogram. Force still steady uniform force. You are still on cruising, right? What you have to find is find the final velocity. Okay, try that. Done? Done. What is that? 50? 50. One second. What is the answer? 50. 50. Then what is the answer? Answer, what is the answer? 50. 50. Let's see what you did. No. Did they give you time? Ah, that's it. I stupidly gave you the time, that's the problem. That's fine. No, this is fine, this is fine. This is fine. Because I gave the time already. So that's the problem. In the exam you don't get the time. If you get the time, you do this way. Now, what you did, now there is a force, right? If there is a force, definitely you have to use the physical. So force is there, m is there, you find the acceleration a. So once you find the acceleration a, so you need to find the final velocity here. So what you are going to use is so v is equal to u plus at. Or you can use v squared is equal to u squared plus 2as, right? But then so now you understand this question is Newton laws plus equation of motion, what you have learned before, right? Combination of those two will give you that. So in the future also they will do that. So as I told you, like that question in the motion, the collision thing came in the light and matter. Okay, so that will do. So okay.
So for this question, if you use v squared,
It's a different answer.
yeah.
That's what I told you. I gave you time mistakenly.
Yes.
Yeah, I understand. But that's okay. But you get a question in the exam, no matter what you use, you get the same answer. So then they will manipulate these values, so that doesn't matter what equation you use, you get the same. So that's why I did a mistake there, but that's okay. I wanted to see like how you are using those two together, and then get the answer. That's it. All good. Okay, so we'll continue.